Okay, so here's the Android app as it would be when we first open it. And right now we need to search for a Bluetooth device to connect to. See the status message telling us we're not connected yet. Here we've got two slider bars which indicate the relative actuator position for both the primary and secondary axes. Over here in the right column where it says NA, once we connect, that will display real-time sensor data for the east, west, and north-south sensor values. Here we've got a set of buttons, auto, manual, and park, with checkboxes next to each to indicate our device status when there's no wind alert, but when there's a high wind condition, this will have a checkbox in it and display the time remaining for our park period since the last high wind trigger event. So moving on down a little bit here, we've got north, south, east, west buttons with a stop in the middle. When we are in manual control mode, we can operate either the primary with the east and west or the secondary axis with north and south buttons. And pretty much any time the motor is running, if you want to stop it, whether it's an east return, tracking, whatever it is, scanning a part, you can press that stop button. It will stop the motor. A nice little kind of safety feature. So now let's start getting into the configuration features. So we've got an option for this M2 and M1. These can either function in a scan mode or set mode. So when we first connect the device, it's good to run it through the scan, and this will set the maximum pulse count for each axis when we scan each axis. And that'll also automatically set the default park position, and if we want to, we can modify that and enter in the actual pulse count over here when we use the set to value. So now we get into the actual tracking configuration parameters. So first is the tracking period. So it's kind of good to note here before we connect to the Bluetooth device here that we've got hints displayed in all these fields on the right, which help tell us what the units are and the ranges for each field's value. So tracking period ranges from 1 to 60 minutes. Tracking runtime ranges from 1 to 60 seconds. Return runtime ranges from 30 to 600 seconds, so half a minute to 10 minutes. Stall period, a quarter second to 2 seconds. Park period, 10 minutes to 120 minutes, 2 hours. So what do these all mean? So the tracking period is the length of time, the interval between our tracking updates. The tracking runtime is the maximum amount of time that the motor is allowed to run during a tracking update. Reducing this number helps reduce seeking, but if we reduce it too much, we won't be able to track the sun properly. The return runtime is the maximum time that the motor is allowed to run during an east return operation, or pretty much any other lengthy motor operation. This maximum gets applied just to make sure that we're not over pushing the duty rating on our motors. Most actuator motors are only rated at 15% duty cycle, so that's something to keep in mind. Stall period. So if we've got the pulse signal hooked up, then we can detect a stall condition by the interval between the pulses. So anytime the interval between the pulses exceeds the value set for our stall period, that will automatically stop the motor regardless of the tracking runtime or values. And lastly, we've got the park period here, which is the number of minutes that the unit will go from auto into park mode when there's a high wind condition. And then now, very at the bottom here, we've got, oops, I didn't really mean to do that. We've got the East Inhibit checkbox, which lets us turn on that option for tracking. Below those tracking parameters, we've got some configuration here for our sensors. We can set the threshold. Didn't mean to do that. We can set the threshold for the daylight level. So the dark star takes the sum of the east and west values from the sensors and adds them together, and if it's more than this value, then it can be in auto mode. If it goes less than this, then it'll automatically do the night park feature. So east return would happen in the morning. The sunlight threshold is applied to our tracking operation. So we won't do tracking unless the sum of the east and west values is greater than this sunlight threshold. So obviously sunlight needs to be greater than or equal to the daylight threshold. We can't set that to a value below, and if we'll see later once we're connected that the slider bars won't let us do that. So, and now lastly here we've got a west-east balance and a south-north balance. So just in case there's something a little funny about our sensors, the signals aren't exactly matched, we can add or subtract a little bit from each side to balance them out and make things aim correctly. Again, at the very bottom here, underneath the light levels, we've got the wind trigger values. There's the current, when we're connected with the Bluetooth device here, we'll see the current wind signal here, trigger level there. We can also enter in that value and modify it, or we can learn the average speed over a minute, learn the peak speed over the next minute, or set it to use neither of those and use the onboard analog reference potentiometer on the Dark Store. So that's an overview of the fields here on our app.